Okay, so I guess we'll start with net ionic equations, and I'll just use an example that I think would be likely to see on the test. Um, so, and this is a really jerry-rigged setup to so you can see this. So just know that. Anyways, so, and I'm gonna go ahead and write this balanced because it just will save time. Because I assume you know how to balance. So um, I won't do a one. It's self-explanatory. Okay, so we have magnesium hydroxide as a solid plus 2HCl, and that's aqueous. Okay, and that yields magnesium chloride, which is aqueous. I'll try and make it where you can see here. And at the end we have plus 2H2O, and that's just off screen there, but that is a liquid. And it's okay that it's just off screen because we're not going to do anything with it. Okay, so whenever you're writing net ionic equations, the first thing you have to do is write the ionic equation. So that's where you split stuff. So anytime you have an aqueous ionic compound, such as this one right here, or if you have a strong acid, such as this one right here, then you're going to split the compound the compound or the acid into its cations and its anions. So for magnesium hydroxide, we're not going to do anything. It's just solid. If it was aqueous, we would split it, but it's not. So to write the ionic, we are just going to start by writing magnesium hydroxide as a solid. And so we have HCl, which is a strong acid. So we're going to split this up. It says split. So, and we're going to just write it how we see it. So we have two hydrogens, and we know that hydrogen has a positive charge. And when you're splitting these up, you want to stick that aqueous with everything that you split up. So we have two hydrogens, we also have two chlorines, which chlorine has a -1 charge, and it's aqueous. Okay. Magnesium chloride, it's an aqueous ionic compound, so we will split. Okay. So magnesium has a +2 charge. There's only one of them. It's aqueous. Okay. And then there are two chlorides you can see here, so we put 2Cl negative aqueous. And there is a 2H2O on the end here, but it's liquid, and since it's in the liquid state, we're not going to split it, so therefore I'm not going to write it just for sake of time. So this here is the ionic equation. Okay, so, but we want to focus on the net ionic. All right, so when we look here, we notice that some of these look the same on both sides. There's some things like this 2Cl negative aqueous, 2Cl negative aqueous, they're exactly the same. And they have to be exactly the same. If this said 2Cl negative and this was a gas and this was aqueous, or this was a solid, this was aqueous, we couldn't do this. So since they are exactly the same, state of matter, charge, quantity, everything, we don't really need them because nothing really, it's just a spectator ion. So what we can do with that is we can just say no. that's not happening. So the only real chemistry that happens here is that magnesium hydroxide and two hydrogens produces magnesium and 2H2O. So our net ionic, after we get rid of the things that are the same on both sides of the equation, we'll have magnesium hydroxide solid plus 2H positive aqueous, which yields magnesium with a positive 2 charge aqueous and 2H2O, and that is a liquid. So that is your net ionic equation. If you have any questions, just tell me.